Now we're going to look at how we can compute a z-test for proportions in the calculator using one of our given functions, where for this, what we're going to do is hit Stat, and then go over to Tests, and select option number 5, where that's what's called the one proportion z-test, one prop z-test if you want to jumble that into one sort of word. But we'll click on this. We have to be careful about our inputs here. We don't have as many, kind of like how with the one proportion z interval we had fewer options. Same thing with the z-test. Here we're going to put in the value for p0, but we put this in as a proportion, where here we're talking about the research that shows 45% have saved money. So this value for p0 is going to be that given 0.45. Meanwhile, when we look at the values from our sample, we represent this as a number of successes along with a number of trials. Where here we had 41% out of 100, so that will be 41 successes in 100 trials. And in particular, we are looking to see whether the percentage is lower than that supposed parameter of 45. So we are going to run a left-tailed test, select the left-tailed option, and then we will calculate. Where if we run that computation, we get from this our z-score of negative 0.80, where we have attached the p-value of 0.21. So if you want to think about this in terms of a p-value approach, we can see that the p-value is considerably larger than alpha, so we would say that we cannot reject the null hypothesis. Or if we want to be sure, we can get our critical value here, where that would be something with an inverse normal computation. Since we are looking for the 1% in the left tail, that'd be 0.01, and we would run this to get a value of negative 2.33, where we can see that with this left tail, the critical value is well below our test statistic. That is, our test statistic is not in the rejection region, so for that reason as well, we would fail to reject the null hypothesis and say there's not enough evidence to support the claim. For a similar example, we're going to look at this case where we have a claim that 51% of adults believe incorrectly that antibiotics are effective against viruses, where we have a random sample of 2,202 adults, where 1161 say they are effective, and we're testing in terms of a level alpha equals 10%. So we're going to go in here, same menus, tests, option 5 for the one proportion z-test, where the supposed parameter we're looking at is that proportion, 51%, and our sample data is 1161 out of 2,202, where we are looking at the researcher's claim here that it is 51%. We're not assuming that 51% is good, we are checking to see if it is good, where because the claim is equality, the alternative would be any form of inequality, that is, not equal. So we run this test, and with our two tails, we get critical values here, that we'll check in a second, to compare with a z-score here of 1.60. And there should be something worth mentioning here with the p and the p-hat, just to be sure. When we're talking about this computation, you're going to see this p-hat, and because the kerning's kind of terrible, it looks a lot like a p. This is not what we want to talk about. What we want to look at is the value up here, where that p-value is about 10.5%, where that 10.5%, it's very close, but it is just a little bit bigger than our value alpha. So it's about as close as we'll ever see on these types of things, but we don't have enough evidence in this case, where if we want to check it with the critical values and rejection regions as well, we can do that, where what we would do is get the inverse normal computation for the break-off of having 5% in each tail. It's one of those very traditional values that we look at. So we will put in a area here of 0.95 to get the upper tail, and that will give us this upper critical value, where the lower one comes from symmetry, but in either case, it's very close. We still have that our test statistic is in between them. So we would fail to reject the null hypothesis, and therefore we say there's not enough evidence to reject our claim, or we may also say that we have some evidence supporting the claim, but it's a little bit murkier.